Hi, welcome back. At another video, we're going to talk about ADLB, laboratory data. Okay, so this laboratory data, it is the BDS data structure. And you check in the Adam implementation guideline. So this is a BDS, basics data structures. So it has the data set contains one or more records per subject, per analysis parameter, per analysis time point. So for each individual subject, we'll be having more records by parameter or by time point, and this is come under basic data structure. Okay, so this is related to the laboratory data. It will be having the similar header part. So we'll be considering the source as SGM laboratory data as well as Adam ADSL data for the treatment, and some demographic information. And we'll be having, there is no my macros, we're not using any macros in this program. So let's continue with this one by removing the previous datasets. If there is any datasets, we are removing by using this syntax. Okay, and we are reading the initially we are reading the all the libraries we required to execute this program: the haven, tidyverse, deployer, hybridate, and admiral. Okay, so we are setting up the working directory right now. Then we're checking the get working directory if it is the right track or not. Then we're gonna calling the SDTM datasets and also Adam datasets. Okay, then we're calling the LB dataset and ADSL dataset. Up to here, clear, right? So we're calling all the required dataset to execute this program. So now when we check the specification here, in the specification we have predecessors. There are plenty of variables we have to derive. So the most of them are predecessors, so it is coming from the ADSL dataset, so we don't need those ones right now. I'm just filtering out those ones. Okay, so we have almost like 15 variables to derive. So these are the we have to derive in this program. So we have a visit n, parcat, and params, oval, base, change, percentages, and analysis baseline flag and shifts. So these are the variables we have to derive in this dataset. So let's sort the dataset first. Then we combine the ADSL. Okay, so sort this one, and I removing the study ID because in LB has also has the study ID and ADSL also have study ID, so I don't want to get conflict with at the end. So I'm removing this part. Then I merging with the left join. I join with this ADSL with the LB by unique subject ID. Okay, and the LB2 is the new data set we have created with along with the ADSL. So they will be having 3920 observations and 59 variables. So 3624 will become as 59 variables. Okay, then when we start with the LB3, so here we have a pipe symbol for continuation purpose, and we have a method function if you need to create a new variables. So a visit, as per the specification, a visit is to directly, oh sorry, I think it's LB. Okay, so we are taking the visit information from the LB dataset from the SDTM and visit num for the SDTM LB dataset. Okay, so a visit considered as a visit and a visited numeric format in the visit num. So because LB dataset already have this information here. Click. So we have visit num in the numeric format and a visit in the character forms. We have these two variables, so we directly map to that. Okay, then we have to derive the param. The param is a combination is LB test in anther parenthesis LB standard stress unit in the brackets. Okay, so LB standard units, laboratory standard units. So how we do that? Case when there is no missing value in the units, LB standard units. When there is no missing for param, you always consider the standard units, not the original units. Okay, then we concatenate with LB test. So we have to give the bracket, then we concatenate with LB standard units and close with the bracket. So this is the way we have to create this form. LB test, in the bracket we have units. Okay, so once we done this one, and if there is a missing values, we give directly LB test. We're not considering that parenthesis, we just keep it as missing. Okay, then if there is nothing information, we keep it as a missing. Okay, that is the param derivations. So hope you understand. If there is no missing values, we have to give the bracket, and if there is a missing value, obviously we don't have the units here in the bracket, so we will be keeping as a missing. And if everything is missing here, if there is a missing in the unit, so we keep it as a missing. And the param cd would directly map to the lb test cd. Okay, that is a code part of laboratory test. Then parcat1 will be having labcat. Okay, assign labcat. Then in the parcat1n, that is in the numeric format. Okay, so when you check the parcat1n, because the category 1 we need in the numeric format because we need to sorting based on that one. I'm creating the numeric format here. If it is parcat1 is here lbcat, it's biochemistry, then we give it as 1, and hematology we give it as 2, because in lb dataset we'll be having 3, right? We'll be having lbcat, we'll be having urine analysis. Okay, so here we have a biochemistry urine analysis, and how do we check if we have laboratory category, how much we have? You can just simply write here, check like the distinct value in the laboratory lbcat, because we don't know, right? So because here we have 3, and we don't know exactly if they have any other departments. So basically in the laboratory data we'll be having only 3 only, but to double check. Okay, so what we do, I'm just put check. So I'm taking the unique function, unique. I'm taking that lb2, this is the data set as a data frame, then we give it as lbcat. So when you executing this part, so you see here, you will be having biochemistry, urine analysis, hematology. So there will be uh, 3 values only present in that labcat. Okay, this is the way you have to check. Then once we were done with parcat1. Okay, so let me execute this part. Here we have lb3 65 variables. We having have here, so parcat1 and parcat1 in the numeric format. Okay, so now we continue with param. So basically we're giving the param n, because with the param n, for each parameter we have to give the number, right? As per the Marshall order, will assign the number. So for that we need to give the row number as a sequence, because we have to select the distinct first. In the param city we have to select the distinct parameter, then we have to give the number for that param. Okay, for this one, param 1. So let me execute this one. So when you check the param here, so you see for these are all individual, like distinct parameters. So this is the codes, and we're giving the individual number for that one. Okay, for that syntax we have executed. Then we have to arrange and we have to combine both. So we have to sort first, then we have to combine lb4 for lb3 to lb. We're getting like param, like the combining the param with lb3 by param cd, like common variable as a param, because we also sort for the param cd here. Then we combine left join with lb3 with the param. Okay, the new data set lb4 has created. Then lb4 we have to sort based on the cat1, because this is the one of the reason for sorting we cannot use the character function, right? So we have to use it numeric format. So for that reason we have to create the numeric format in the param1 and cat1, because it has the bds data structure is each subject we have per each subject we have more recurs per parameter per analysis time point. Okay, that's one of the reason we have to use param and visit wise, time point wise. Okay, so we have to sort this one. Then we have to do with remaining variables, that is aval c, aval unit. If we check here, so these ones are done. Up to here we have done. Then we have to do eval C, eval unit. So this is directly have to measure the numeric format of laboratory standard result. Then we have to use for eval C the character format of laboratory standard result numeric format. Okay, and then we have to directly map to the standard result units for the eval U. Tell us the group by, we are taking like individual group by taking the parcat 1 param. So because they have each subject have a number of records, right? So we make it as a group. Then parcat we rename as parcat 1 to rename as parcat. Then we are creating the eval we're giving the laboratory standard result in the numeric format, because this is the integer part and this is the character form. So for that we have to convert into the character format. Then we are giving the units, our units here directly mapped to the particular variable present in the SDTM laboratory dataset. Okay, so these three are done. Then we have baseline flag. When you check the baseline flag, these three are quite straightforward, so simple. Then baseline analysis, baseline flag. The baseline visit assign flag here 0 time point considered as a base point. So the prior to administration, those value will be considered as 0 time will be considered as a baseline flag. So here if else, if a visit equal to 0, so when you check laboratory data on this one, you check lab 4, so analysis visit numeric format. So you see this is 0 considered as a screening. The period 1 will be giving the treatment. So this value will be considered as baseline flag, the baseline value. If a visit equal to 0, then we give it as S, otherwise missing. And the base also the same thing. If analysis baseline flag equal to Y, then we give it as a base as eval, else missing. Okay, so when you check the specification, baseline value refers to the last measurement made prior to administration of the first dose of the study medication. Okay, the baseline value refers to the last measurement made prior to administration of the first, that is in the that is we consider as a, we consider this one like screening, before screening, the 0 time point. Okay, so if it is Y, then we consider that eval value for the base, and if it is missing, we consider as a missing. Okay, clear. Next we have shift 1. So this one is done. So next we have a shift 1 here. Shift 1 is a baseline value, refers to the last result prior to administration of the first dose of medication. It will be the similar like baseline flag. So if a visit in equal to 0, then we giving as a laboratory range indicator. Okay, the shift 1, why we have to give laboratory range indicator? Because the shift, it happens before administrating the drug and after administration, the what is the changes happen. So if when you check the shift laboratory range indicator, you have normal, high, right? In the screening, for example, if the patient has normal conditions after giving the medication, the patient the particular parameter reaches to high, so the shift is happen. So that's the one of the reason we have to give it in the range indicators. In the in the reports we'll be having a shift table, so for that we have to uh, have this variable to show them that what is the shift has happened after giving the administration, after giving the treatment administration. Okay, so then when we continue with another variables, that is a change. Done. So we have change and percentage of change from baseline and percentage change from baseline. So this is simple math, nothing but eval minus base, and this is the formula eval minus base by base into 100. So these two has to be done. So here we have to consider if base is not equal to missing and eval is not equal to missing, then we have to give eval minus base, else missing. Okay, and percentage change, if base not equal to missing and eval is not equal to missing and base not equal to 0, okay, then we have to give eval minus base divided by base into 100. Okay, so this is a quite straight formula, but make sure you should not have any missing values even in the base. Otherwise, if you have a missing values, it will give a missing. So thereafter we'll be having, so the next one is the treatment assignment based on the A visit. So for the treatment of for the laboratory, like if a visit equal to period 1, then we consider as the planned one of the treatment, planned period 1 of the treatment. And if a visit equal to period 2, then we are giving the value as a treatment 0 to p, and else we have given as a missing character format. Then we do the similar, like if it is period 1, then we give it as a TRT01P and numeric format, and the TRT02PN if it is period 2 a visit equal to. And similarly, if a visit equal to period 1, then we have to giving we have a given like TRT01 actual treatment, uh, and if it is period 2, then we have to give 02A treatment, and if it is missing, we have given the numeric character format of missing. So the same goes with the numeric format. Now after that, the ADT here tells ADT is basically taking that analysis date from the laboratory data, the laboratory date. If, for example, if you check LBDTC here, okay, so the analysis date is nothing but we're extracting the date uh, from the LBDTC in the format of year, month, and date. And if it is the length of the MDT is greater than or equal to 10, then we give it as we give it as a format of year, month, and date. Else we give it as a missing. And ADTM is analysis date and time is just directly giving that the date concept. But here when you check the LBDTC, there is no time specification here. It's just only having the date. So anyway, there is no time point, so it's just date point currently there. So but we have to map to the LBDTC here for edit time. And the next, when we count anal 101 flag, anal 01 flag, this is nothing but if you have not missing a wall, so if that record we consider as a Y, and else we giving as a missing. So anal 01 flag is nothing but if you have not missing of a wall, the initial part, then um that record we consider as a Y, else we're giving as a no. And a period, see, this is the character format of a period. Case when the a visit in the 0 and 1, then we give it as a period 1, and a visit 1 is greater than or equal to 2, then we give it as a period 2, else we give it as a NA characters. This is a similar thing we did in the adverse event dataset in Adam datasets. So a period is a numeric format. If it is a percentage in 0 1 in 1, then a visit greater than or equal to, then we give it as a period 2. Okay, then the last one would be the analysis range indicator, that is directly we map to laboratory range indicators. For the numeric format, when you have a low, we give it as a 1. When you have a normal, we give it as a 2. When you have a laboratory range indicator, when you have high, then we give as a number 3, and the abnormal we give as a number 4, and else we give it as a missing. So then we have ungrouped that because we have did group by right, because it has each record has per category per parameter, right? So at the end we have ungrouped that part. Then we select a required so when you check the specifications, so we have covered all of them, and the most of them are coming from the ADSL, right? So we have covered all the required um, variables we have to derive. Then we have to select the variables, then we have to apply similar fashion, we have to apply the labels as per the specification. Okay, then we give the labels to individual variable. Okay, so here we done, then we call that library, then we updated the labels to that particular labels. Okay, so when you check the final data set here, ADLB, so we will be having almost like 48 variables, then we'll be having that the labels here for individual variables. Okay, we have all the variables required as per the specification. Then we save it as a ADLB in the RDS format. So when you go here, you will be there, so you just control C and paste it in the here in the data sets. Okay, so the most important part we have to understand in this adverse Adam LB data set, uh, percentage change, and param cd. So these four are very important to derive. Most of the time we'll be having three different categories: biochemistry, hematology, urinalysis. If the information are coming from the central laboratory or the local laboratory, so these are the three classification we'll be having category wise. You have to be get that those information. Then the base value, how we give the base value, how we give the shift value. So these are the information we have to be very careful when we are deriving these variables. That's it for today. Thank you so much for listening, and we'll continue for other data set tomorrow. Thank you.